Hello and welcome to day 22 of Leetcode Daily Challenges. Let's begin today's challenge. Question 472, concatenated words. Given an array of strings, words without duplicates, return all the concatenated words in a given list of words. A concatenated word is defined as a string that is comprised entirely of at least two shorter in the given array. Okay. So the example here gives us an input array words with cat, cats, cats, dog, dog, and so on. Hippopotamus, rat, dog, cat. And the output should be cats, dog, cats, because it is comprised of cats, dog, and cats, which are both words in the input array. Dog, cats, dog, rat, cat, dog, cat. Okay. Okay, this all makes sense. Input cat, dog, cat, dog, cat, dog. And some pretty generic constraints, nothing too special, nothing that would change up the algorithm that I'm thinking of. And what I'm thinking is obviously we have to iterate through each word, and the condition by which we add our word to answer is going to be that it is comprised of other words in the input array. Okay, so cat is the smallest, or one of the smallest words here, and obviously this is a base string. So maybe we could think of the words in the input array as two of a kind. Either it's a like a Venn diagram. Either it's a building block word or it's a destination word. And there could be an instance where it's both a building block word and a destination word, but this shouldn't change the generic approach where, let's say that we're looking at this array here, cats, dog, cats. The approach here for me would be that I start iterating through each. Basically, I have a start and an end, where the start is pointed initially at 0 and the end at 1. And this would give us the letter C. Let's see, the next one would be 0, 2, and that would be a CA. And all while this is happening, I'm checking if this resulting subarray or substring is part of the initial list. And finally, I get to 0 and 3, which actually gives me a cat. At this point, I would change my starting point to be 3 and dive into this hole where I start looking at S. Okay, so maybe I should inclusive, exclusive. So 3 is going to be here, so cat exclusive, inclusive, exclusive, 4 and 3. So this is looking at S, and so on. S. And actually, this is going to be a dead end because there's no substring that starts with S. However, if I was to dive out of this, when I reach the end and realize that there's nothing in here, I would dive out of the inner loop and look at my next option, which is going to be 0 and 4. And this happens to be also a subarray or a substring part of words, but the special thing about this one is that 4 and 5 will eventually lead us to exploring dog. Okay, so I think this is, so obviously D, then this is 6, this, and all of a sudden we have a dog, which is another substring, or another element in words. And this eventually would lead us to finding that this is actually part of our answer. So okay, how would we implement this? I'm thinking of pretty much exactly what I depicted here. So a 2, except okay, I want to make one modification. I want to populate all of this information in one go. So while exploring a string, I want to know that, for example, this is a potential ending point, and then also, so this would be like a true, and then this is also potential ending point, and this is also potential ending point, and this is also potential ending point, and so on. What this lets me do is, once I populate this whole intermediate data structure, probably the proper name would this be proper name for this would be dynamic programming data structure. But once I populate it in one go, I don't have to make that recursive definition or recursive jump to figure out if the next word that or the next substring that I'm about to explore is part of the original words list. Okay, so with that being said, let's get to the implementation. I think I'll have an answer array, and for end in, let's see, it's just going to be a range of len. Oh, no. For word, in words, I am exploring words. I have to explore those. I have to basically have all permutations of start and end under the condition that start is less than end. So for end in range len word, for start in range 0 and end, and I'm going to do the following. If word, so if my prefix is part of or is in words, that means that I'm on the right path, and my intermediate data structure, which is initially just programming false times, let's actually outsource this to a variable. If my prefix is in words and prefix is being s of substrings from start to end, then set dp to end equals true. So this would be equivalent of me doing the following. I'm traversing first cat, the first word that I set, and my data structure, which was essentially first f, 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 f. Let me f, 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 f. Yeah. The first, I'm going to turn this into a true. What this is going to allow me is once I get to cats and turn this to true, since I'm iterating over all possibilities of start and end, there will come a point where I'm looking at this as a potential start of a string. And this would actually, no, it would be this. And this would be another true, because the condition here is that I've ended my previous prefix on a true, which means that it's part of the words array, and also my current substring that I'm looking at is also a true. And then the final result is my, when I'm exploring this, inevitably, I will also find this to be true because of the same logic that I applied to previously, which will mean that I am looking at a valid answer. So, what does this mean? If, let's say, prefix is equal to word start end, if prefix in words, then I'm going to say dp and true. And that is pretty much it. I'm pretty sure that at the end of the day, at the end of the traversal of, or the permutation of all end and start, with the condition that start is before end, if my last character or my last element of dp is true, means that I was able to populate, or I was able to reconstruct this whole word using just words or smaller words in the input. So if dp -1, answer append word, and let's return answer. Let's return answer and see where we are. Okay, it's already taking a lot, so I am also recording this once again a day late. So, okay. Oof. So let's debug a little bit, because I don't understand why cats should not be a part of my response. The debugging is pretty simple. I'm just going to print dp here and see what I'm getting. So my first input is cat, and okay, right away I see an issue. The first element should be should be set to true. That is because that is my starting point. The starting point saying that the initial how do I say this? My first prefix in a given word is only going to execute. Okay, well, this is already wrong. My first, yes, this shouldn't have never happened. My first prefix in a word should only be there if it was previously the previous prefix, or in this case, no prefix is true. So I also need an and dp start to be true. Let's run this. Let's see if, I think this drove us further away from the answer. Let's look at this. Okay, at least all of them are being populated. Okay, the first value is now true, which means that we have a starting point for building our collection of prefixes in this DP. Okay, what I'm also don't understand is why is it that for some of them I know probably what I always do this incorrectly. I always confuse the how to treat ends and starts of arrays. So for example, at this point, I'm starting end from 0, which is incorrect because we're starting start and end from 0. This should be 1 plus n, or 1 from 1 to n. We should always be starting after start. Let's see if this. Oh, and additionally, since we are exclusive on the bottom end, yeah, since we're exclusive on the bottom end, this is why for some of these fields, the last value is false, we have to say +1. And this would actually also lead this to be 1 bigger than it has to. Okay. Sweet. Okay, now the output is way bigger, and for some reason it's including all of the input words. Let's look at our debug. Why is this true? So it seems that for the last Boolean value of all the DP arrays representing words is true. And I'm wondering if that is because when I'm populating this last, or when I'm deciding if my prefix is a valid prefix for my word, it could be catching the word itself. And if that is true, then all that we would need to say is that prefix does not equal word, because the condition here is that, or the situation here is that when we're exploring the word cat, it will run through all different permutations of start and end, but the last permutation that it's going to run through is going to be the word cat itself. And if that meets all of our conditions, previous conditions here, that prefix is in words, and DP of the start, which is the first element of the DP array, is true, then it would just set the last element to true, which would make it return as if it's a valid answer. But this right here will prevent this additional constraint that the word cannot itself be the prefix, will prevent that. And let's see if this works. Time limit exceeded. And I am printing a lot of words. Okay. So so somewhere in here I'm also Let me just check why. Terminate. Whoa, never seen this before. What did I change here? The end prefix does not equal the word that I'm currently exploring. Words start and end. Let's go back to debugging and let's actually go back to this more sensible situation where I am just returning all of them, and I'm just returning all of them and setting all the last values to true, probably because I removed that last condition. Now, to get back to okay, let's talk through this one more time. Is concise. Okay, so we have an answer array. We are looking over all of our words and we're doing the following thing. First, constructing or calculating its length and constructing an intermediate data structure called DP, which will store all prefixes, all valid prefixes, and in all the valid prefixes only in the correct spots, in the correct places. So a valid prefix could be the first prefix, but in order for there to be a second prefix, it has to start where the first prefix started. And what lets us do this is this DP intermediate array, which is set to initially all false. And this is done, and it's set to one more because we are treating end as a exclusive value. So we're starting off from 1, exclusive 1, and ending at n plus 1. We are saying that start in range 0 to end, prefix equals word, and the substring is from start to end. So within here, since this is going through all elements or through all indices in our word, this will go also through all indices in our word. So the prefix word start to end here is correct, and the prefix is correct. And my condition here is that prefix in words, if prefix is in words, so if this is a valid prefix, and if DP, okay, if the start is true, and why am I wrong? If prefix, you know what it could be? How about we have a set here? Set of words. It might be that word in list doesn't it might take it too long to find. So that's what I'm thinking the time limit exceeded could have been. If we have a set, okay, so if we have a condition like this, prefix in S, for a list, that would take O of n being the length of the list. For a set, however, that would be O1. And so I'm thinking that our previous condition here, where we said that word does not equal to prefix, was actually correct, but we were hitting a time limit exceeded due to this. There we go. Got it. Okay, so yeah, the lesson there is that if you want to, yeah, this is something that you don't see in Python because Python is so grown and mature, but if in other more, how to say it, less mature or no, more mature languages where you have to implement things by hand, you would actually know that a hash map, which is what a set is, or a hash set, the operation to find a value in it takes O1, whereas to find if whether to find an element in a list, it would take the traversal of all the elements. All right. So yeah, this is the answer. Let's look at some quicker responses and then sign it off. Mem. Very similar. And then they're doing a DFS, deep first search of the word. DFS, oh, for word and words, do DFS. So this is actually very similar to what I was proposing in the beginning, where we do a deep dive into our whole word by our prefixes, which are actually other words in the array. So yeah, a DFS approach here is completely valid as well. And they're actually, if you look carefully, they're doing the same thing. For words and words, for word and words, they're doing the deep dive, except that we had an intermediate data structure, which was a list that kept the valid prefixes as Boolean representations in it. Here, they don't have any intermediate data structure, and they're just traversing the whole word, which apparently is faster. Okay, well, thank you for watching, and I'll see you next time.